Good day, good day, good day, good day. Welcome back to our YouTube channel. So if you're new here, my name is Stifler, and if you've been here for a while, welcome back. So we are still preparing the matrix on their trial. So today we are working on work, energy, and power. Just a couple of questions, and I'll be explaining how you can answer some of the questions. So here with us, the first question that we're having: a 12 kg block is initially at rest at point A. So here this is at rest, so it means that it is not moving at first. At the bottom of a rough inclined plane. So once you hear rough plane, so it means that there is frictional force. So put that in your mind. There is frictional force. And the block is pulled up the inclined by a constant force. So it means that we are also having a force that is constant. So what do they mean by the constant force? They just mean that the force is not changing, the force is remaining the same. Acting parallel to the incline, the block reaches point B, which is at a vertical height of 4.5 meters. So here the height here it is 4.5 meters. So it means that the work is done to move from A to B with the speed of 2.25 meters per second. So it means that the speed here now it is 2.25 meters per second, but initially it was 0, as seen in the diagram below. And the first question says, define the term non-conservative force. So what is a non-conservative force now? So a non-conservative force, it is a force that when work is done, on an object, the object that is moving right between 2 points, it depends on the path taken. So in simple terms, we can say that because you know that sometimes they need their definitions, and this is the definition that they will need you to write. But in simple terms, a non-conservative force is when it is moving, the energy is not conserved. So the energy is not conserved in this situation. That is a non-conservative force. It doesn't conserve the mechanical energy of an object. However, if it is a conservative force, the energy is conserved between any point, and also the work that is done on an object, it doesn't depend now on the path that is taken if it is a conservative force. So let's move on to the next question. Draw a labeled free body diagram for the block when it is pulled up the inclined plane. So 4 marks. So 4 marks simply means that there are 4 forces that we must draw. So how many forces can we see here? So already we can see that there is frictional force and there is the force applied. However, we know that each and every object, it also have gravitational force. So it has Fg. And if any object is on a plane, it will also have the normal force. So we have the normal force as well. But how can we draw now? So drawing this free body diagram, you have to also remember that we're having an inclined plane there. So it means that we are going to have the normal force. We also have to have this force that is parallel to the incline. And frictional force always opposes the motion. So it will act backwards. Frictional force, and we have Fg, which is also acting perpendicular downwards. So the Fg always acts perpendicular downwards. So these are all the forces that we're having on this object. And we can move on. They said calculate the total work done on the block by the non-conservative forces when the block moves from point A to point B. So now we want the total work done by non-conservative forces. So how many non-conservative forces do we have? We have two. We have frictional force and we have the force that is being applied. These are the forces done by non-conservative forces, right? So how do we calculate the work done by non-conservative force? We know the formula that we use to calculate the work done by non-conservative forces. We know that work done by non-conservative forces is equal to change in EK plus change in EP. So we are trying to calculate work done by non-conservative forces, which will be half mv squared final minus half mv squared initial. So this is standing in place of the change in EK, plus mgh final minus mgh initial. So what do we have on our object? We know that initially it was having 0, velocity was 0 here, so it means that initial kinetic energy is 0, and also the height before it was 0, so it means that also here we have 0 potential energy. So now how can we deal with this one now? So it means that our work done by non-conservative force will be equivalent to half, and the mass of this object, it is 12 kgs, so 12, and then the final velocity being 2.25 squared minus, so this one we said it is 0, right? So minus 0 because initially it was at rest, and then plus mgh, which this would be 12 multiplied by 9.8 multiplied by the height. The final height, we told that this is 4.5 meters minus 0, because still this is 0 because initially the height was at 0 there. So now it's just a matter of calculations. So work done by non-conservative force now becomes this. If you multiply out, you can do that with a calculator. You can just punch everything inside the calculator, and then we can find 559.58 joules. So this is the total work done by all non-conservative forces acting on the object, like that. So this was 5.3. We can now move on to the next question. Let's see what it is about. So now they said, and it was just for marks. No wonder it was that simple. The same constant force F now moves the block at constant velocity across a rough horizontal surface from point B to point C. So now we are told that the force now didn't change to move from point B to point C. The force is remaining the same, but yet you don't know what was that force, right? As shown below. And again, we are told that it is moving at constant velocity. What do we know about constant velocity? It means that our acceleration is 0. Constant velocity just means that the acceleration is 0. The force F acts parallel to the horizontal surface. So now F is still horizontal to the surface. The magnitude of constant frictional force acting on the block while moving from point B to point C is 42 newtons larger than the magnitude of constant frictional force acting on the block when it moves from point A to point B. So before we were having the frictional force, which we don't know again, but now they're telling us that now the frictional force is 42 newtons larger than before. So it means that if this is the frictional force from A to B, it means that now our frictional force from B to C now, from B to C becomes frictional force from A to B plus 42, because we're told now it is 42 newtons larger than before. So this is our new frictional force now. So they said calculate the distance from point A to point B. So what can we do with this one? What can we do? So I think here, just because we don't know our force and we also don't know the frictional force, we need to make an equation that relates the two so that we can see how we can solve that. But there's something else that we are not talking about, which is acceleration being 0. What do we know when the acceleration is 0? When acceleration is 0, we know that our F net is mass by acceleration, but since this is 0, it means that our F net is equals to 0. So what do we know about F net? F net, it is the sum of all the forces acting on the object. So we can see that from B to C there, this object is on a horizontal surface, which means that we are having normal force, gravitational force, and we are also having frictional force and force applied. So which means that we are only having two forces acting parallel to the motion. So it means that our F net now becomes force applied minus frictional force being equals to 0. But what is our frictional force now? So it means that our force applied minus frictional force, now it becomes frictional force plus 42 is equivalent to 0, which then mean that our force applied is actually frictional force plus 42. So our force applied didn't change. So now it is, our force applied didn't change. So relating it to the previous one, it means that our frictional force plus 42 shall be equivalent to the force applied. But we didn't answer the question. The question is actually saying we must do what? Calculate the distance from point A to point B. So now, how do we calculate our distance from point A to point B? There's something that we already calculated from point A to point B. We already calculated the force, the work done by non-conservative forces, which we found out that it was 559,58 joules. This is the work done by non-conservative force. So what is the work done by non-conservative force? Because previously we used that work done by non-conservative force is equal to change in EK plus change in EP. But you also know that work done by non-conservative force can also be called the force that are done by the forces, the non-conservative forces multiplied by the displacement. So this displacement means point A to point B. So now what can we do? So this we can substitute 559,58 equivalent to. So here we know that we're having two forces. We're having force applied and we're also having frictional force. So now it means that the force applied and the frictional force, we're having this, right? So we can actually substitute that. Our force applied, right, minus. Why are we saying minus? Because already we can see that the force applied, it is a positive force that is going up, but the frictional force, it is going against the motion, so it should be subtracting. So subtracting frictional force should give us the change in x, like that. So this becomes 559,58 equivalent to. Already now we know the force applied in terms of frictional force. So we can substitute that. So our force applied is frictional force plus 42. And then this should subtract the frictional force that was there at AB. all this multiplied by the displacement. So frictional force and frictional force can cancel because they are subtracting each other. So 559,58 becomes 42 multiplied by the displacement. And now we can divide both sides by 42, which means that our displacement can become 13.32 meters. So it means that our displacement from A to B is that. The only thing that you can take from me is know all your formulas. Each and every statement that you are given, it makes sense. There is sort of sense that you can get from that. The same constant force, F moves the block at constant velocity. So always remember that. What does constant velocity mean? So that you can be able to calculate whatever that you are trying to calculate. And also you were told that the force was now 42 times larger than the magnitude of the frictional force before, right? So also you need to make sense of that. Yeah, so we can still continue with this document. I think it is best if I can cut the videos one by one, treating each and every question. But don't forget to subscribe. We're coming back with another one.